a little chit chat thing. All
I gotta close out a bunch of browsers here.
right. Okay, so we are now live. I'm gonna go ahead and start posting on the Twitters and all that.
All
We
right.
should probably pick a few channels to post in the Dash commune.
Commune.
Community.
That changes the meaning, doesn't it?
I guess it does. I guess it does.
I can close out the concerned.tech tab as garbage. I know
Oh,
it's not totally garbage, I know, but it
yeah.
wasn't very well written.
Uh, well, I think it was well written to the audience that it was intended for. It's not very technical, is the
Yeah.
problem. So let's see. At Ryan and I are at it again. Blockchain debate.
How is this
Live
is this part of the
streams.
debate series?
Yeah, I mean, it's not necessarily a debate per se, but I'm going to throw it in there.
Sure.
So it's not really going to be debate. By the way, we've got 2 minutes and 30 seconds about before we are live.
All right.
So
Still closing out tabs. I'm trying to get this fan to turn off.
Where should I post this in the Dash group? Should I just post this in general?
Yeah, just go with general.
Boom. Oops. Let's see. Should I post it in Dash Devs too?
Sure. Yeah, in the different Discord, the dev Discord.
Yeah.
Yeah.
All right, we got a minute. A minute and some change here before we go ahead and get started. Let me go ahead and open up the chat and make sure that's all there. Boop, 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 boop. Okay. Chat's open. We've got somebody to say hello to online. Hello, online person.
Oh yeah, so people can ask questions, I guess. This is open to the public.
Yes. But I think primarily what this is going to be is it's just you and me. We're just having a chat. If somebody wants to tune in, they can tune in.
Great. Yeah.
So T-minus 1 minute.
I'm gonna try to steer you to the fundamentals and to the basics, because I want whoever's listening to this, I don't want to assume that they know much. I want to assume that it's an intelligent yet uninformed audience, so that we don't have to use analogies and stupid things like that, right? But we can tell them how things actually are working. But
well, I tend to use analogies just because the way that I am. But
I know, but I just hate when people explain things through analogies. Just tell me how it actually works.
Well, you rebut me when I do that then.
Okay, I will. Because that's one of my things is, to me, an analogy is actually harder to understand, because you have to understand the analogy that they're making and then do the translation to what it actually is that you're talking about. So it's like 2 steps instead of just one. I think a lot of people kind of use analogies. I'm not saying that you do this, but a lot of people, they'll speak in analogies because they don't actually know how something works.
Right.
So they'll just kind of bail out and use an analogy to, they kind of blame it on the listener and saying, "Oh, let me simplify this for you to help you understand it." But actually, it's because the person that's trying to explain it doesn't really understand it.
All right.
Anyway,
Well, shall we get started?
yes.
Okay. Well, hello, and welcome back, everybody. This is more of a semi private conversation between Ryan and I that we're sharing with the world. Not so much debate style as much maybe educational style, but I'm labeling this under the blockchain debate series because I am. Anyway, so Ryan, I'll go ahead and let you lead in. And I guess I'm in the position of answering questions and posing problems, and you're in the position of delving deeper.
Yeah, I think let's frame the overall goal here. I think the overall goal here, and you can correct me if I'm wrong, because it's kind of a hybrid between your motivations and my motivations. So let's get on the same page. But I want to know the fundamentals, and sometimes I'll probably ask questions even if I know the answers, just for the sake of a thorough discussion. And then sometimes I'm asking a question that I actually don't know the answer to, and I'm not going to tell you which is which because that way I
Use
can
my
look
psychic
smarter.
ability.
Yeah, just kidding. But I want to know how the internet works at a fundamental level, including all the different layers, not all the different layers, but including the main layers that matter to us, in the context of basically, we want to know if we're architecting the dash tooling correctly, given our options with how the internet can and should work, something like that.
Okay.
So I guess we could start by just asking a question: what is the internet?
Oh,
I'm super blurry here. I guess that's fine, but I don't know how to fix that.
the
What is the
internet
internet?
is a set of standards that reflect both in software and hardware that allows computers to speak to one another in a peer to peer fashion as equals. That's what I think of as the internet, as the specifications and the standards kind of define it. It's a way of computers to efficiently speak to each other across the globe as peers.
Okay, so when you say peer to peer, that makes me think that if your computer, let's say a traditional client server model, if I have a server and you have a client that you're connecting to me, you don't actually connect directly to me. There's all sorts of, like, what are the protocols that connect us together, I guess is the question. Because we don't obviously have a hard line connecting your computer and my computer. And even if we did, um, that still leaves a lot of questions to be answered. Uh, Namely, like, how do we know that we're talking to each other? How do you call me? How do I answer? Um, those kind of things.
Okay, well, in that regard, I would say that it's the same as the telephone system. Well, now it has replaced the telephone system with the same system. You have So at your house, you've got a cable that goes out to the yard to one of those green boxes. That green box has a bunch of other cables inside of it. It goes down the street to a bigger green box that goes, uh, down the city to a bigger green box. That goes to some major metropolitan. Well, it first connects into some company that's handling those subscribers. Then it goes into a big metropolitan area where it connects to what's known as the backbone. So, for example, we're in Utah. All of our traffic, no matter who you're subscribed to, goes to the fiber backbones in Salt Lake City. So anything that we do first goes to Salt Lake City. So for example, if I'm on Comcast and you're on that dial-up provider, what's its name? The one with the green and the yellow symbols. Um, and
CenturyLink.
CenturyLink, there you go, right? So in order for our computers to talk to each other, because we're on separate networks, we're first going to go to Salt Lake and then come back down. But
What
all
do you
of
mean because we're on separate networks? We haven't talked about networks yet.
Okay. So the network of subscribers. So if I am on um, Google Fiber, then I pay money to Google Fiber and I use either lines that are put in the ground by Google Fiber or by some contracted company that they piggyback off of. And there's going to be layers of these. And then you also have kind of the cross communication because a lot of these wires are going to be used by different companies and they basically pay rental fees on the wires to be able to have their customers use it as well and might have some sort of priority stuff or some such. But the essence of networking is what's called a switch. And this comes from the telephone switch. It's a box that has a few wires coming in, and there's an electrical signal. And every time the signal wants to communicate somewhere else, it starts with basically Morse code with on and off, on and off, on and off, with a timing that creates a packet. So bits are the result of an electrical signal going oscillating between high and low according to a timing mechanism. So the first set of information that will go into a switch will be essentially where this should get connected to the IP address, which is the same as a phone number except a little bit longer, but the same basic system. So you've got an IP address that's on in that packet of information, and then perhaps the length of how long the packet is, and maybe some version information, which version of the internet protocol is this using, or some special options or some stuff like that. I'm not super well versed into all of that really heavy IT stuff, but basically, packet goes into the switch, and the switch has enough information in it to know, can I get this packet to where it needs to go? So each of the wires that's plugged into that switch has shared some information. If it's another switch or a router, it will share information about what addresses it can service. And so there's this hierarchical system of addresses where, based on what an address is, you can know the switch that it needs to go to next. So it figures out, it has this routing table that's basically a little local lookup, and it figures out, does this packet need to go somewhere here connected to the switch, or does it need to go out to where the switch connects up to other things? And then at some point, it reaches a switch that knows what to do with that packet. It knows where that packet is supposed to go, and it takes it there.
Okay, so we've talked about a little bit about like you've mentioned things like IP address,
Yeah.
and I think everybody's seen one of these IP addresses. They've got it's four blocks of three numbers, basically, right?
Well, the
Uh,
newer ones are quite a bit bigger, but yeah, that's the limited set of IP addresses that have been exhausted. Are the four blocks of three numbers.
yeah, so let's just. I mean, I know that there's the new one that's not that new anymore, but it's. I know that's out there, but people aren't. I don't think people need to. We don't need to talk about that one to get the idea.
It
The
is
idea.
important in the discussion of Web 2, Web 3 decentralization. It is
Okay.
critically important, but no, we don't need to talk about it, the idea. It's just four times as many uh, four times as much information. 32 bits is an IP address, which means that there's 4 billion addresses. If you were to use all of them efficiently, you could address 4 billion different devices. And then there are 128 bits in an IPv6 address, which sounds like it would be, oh, it's can do 4 times as much because it's 4 times as many bits, but actually, because the way the addressing scheme works, it's to a power of 2. And so it ends up being pretty much more than the number of atoms than there are in the universe. You could have addresses to spare after you gave each one
Okay.
an address, kind of thing.
Okay. So yeah, the next version has many more options. But in general, though, who is assigning who is assigning these numbers for these devices? So my understanding is that every device has an IP address, but how does that device get that IP address? Is there some kind of registry, and
Yes.
what are the permissions involved with that?
So I'm not really versed with IANA, which is the International Association, no, International Assigned Numbers Authority. But IANA is the political organization that manages who owns what IP range. And all of them have been sold as of a few years ago. There were zero IP ranges left in the public space. All IP addresses are now privately owned.
Okay,
Oh,
so this is good to know.
at least for the IPv4, which is what we were talking about, as opposed to IPv6, there's an infinite number, essentially infinite number of addresses.
Okay,
Um,
so essentially, I mean, this is a lot like political jurisdictions where there is no more virgin land to be settled and to be homesteaded. You can't find anywhere on Earth basically that some political entity hasn't claimed it as their own, and so you are going to live in some nation. And so, in by analogy, again, so I'm guilty of this, but this doing the analogy thing. But what you're saying is all the IP, we're all renters here. We're all renters in the internet.
yes.
That's kind of hmm,
Yeah,
that's
you
kind of
you
sad.
you as an individual couldn't get an IP address, and it wouldn't really even make sense because the IP address from our perspective is ephemeral. It's not something that you care to own. It's not something that would really benefit you to own. And you couldn't take it with you because of its physical properties. The cell phone system, they've done magic with lookup tables to make it so that you can transfer a cell phone between one carrier and another and, get an area code in Virginia and then bring it to Wisconsin. Uh, the IP system can do that to some degree, but not all the way down to the individual level like the phone system can.
Okay, so you're going to get your IP address from some other agency.
Yeah, so you are a subscriber to some ISP, internet service provider. And they, if you're lucky, if you live in the United States, for example, will give you an IP address. In some of the poorer nations, I have heard that you will get a private address. So you actually are still facing the same dial up problem as we faced back in the 90s, where you cannot actually get access to the internet from your computer. You have to go through a tunneled proxy to get that access. And there are three IP ranges that are for that purpose. Everybody's familiar with, well, that's ever done anything with, having to set up a Wi-Fi router, 192.168. And then you might be familiar if you're more in the enterprisey space, 172. And then a lot of the prosumer stuff also has the 10.0.0. So
Hmm.
those numbers are reserved. They cannot be purchased. They are reserved for internal use, as well as 127. But outside of that, the blocks are sold. So they're sold to Amazon, they're sold to DigitalOcean, they're sold to Google, they're sold to CenturyLink, they're sold to
And
Vodafone.
they're sold by this IANA group or whatever it's called, right? To
Yeah.
these large corporations. Now, do you have to be a large corporation or can you be some kind of nonprofit organization?
Let
What
me
kind
let
of
me
organization do you need to be to get to have access to one of these IP blocks?
um, let's see. I'm just reading from IANA.org, protocols apply. The majority of protocol registries have no special form in order to accept registration requests. For these, use the general assignments form. However, if the registry listed on the following table, you should be specific. You should use the specific application template instead. I I don't know. So I don't know. I said that they're sold. Maybe they're assigned without being sold, although I don't think that would happen because then that somebody would just they're a limited resource, so somebody would just snatch them all up. So I'm not sure how the assignments are made specifically, but yeah, you basically have to be an internet service provider. You have to be in the realm where you would be allocating millions of addresses.
Mhm. Okay, yeah. So one of the things that you and I discussed as part of what we wanted to talk about in this call, you've made a claim essentially that the internet is decentralized, or the internet is not decentralized. What's the term?
It is the trifecta. It's distributed, it's decentralized, it's all the things that are desirable with,
It's a federation,
yeah,
is I think
federation.
is
Yep.
what the term that you used, right?
Yep.
What
Yep.
I'm familiar with the term on a political level, which basically means like there are certain specific nodes that are important, and then there other nodes branch out from that. So it's not totally it's not a mesh distribution where every node is equally weighted and equally important. There's like there are many nations, and then at least the United States, there are different states that make up those nations, and so that was supposed to be called a federal republic,
Right.
where you have a group of so what were supposed to be sovereign states, and then they combine to make a federal government, basically, but without giving up sovereignty. They are a federation of sovereign states, and so that's what you're saying the internet is like, um, rather than some. It's not truly peer to peer, is what I'm kind of getting at. It's
Well,
peer to
it depends on what you
company to peer,
it,
peer
it
to company to company to company to peer.
it depends on how maximalist you want to be. Because it is the natural, it follows the natural system that there are always hierarchies whenever there's communication. You cannot have any. So for example, you and I, we can have a peer-to-peer conversation by virtue of the fact that we're talking one-on-one. Our communication is encrypted, although we're sharing it with the rest of the world. And so we are operating peer to peer, but yes, there are aspects of the technology that we're using that have certain constraints. We're using a website that is neither your computer nor my computer in order to establish this connection. Now, we could run the software ourselves. The same software that we're using right now, I could run on my computer, and maybe at some point I'll figure out how to do that so that it could be more peer-to-peer. But there's layerings, and the important part is that you can pretty much pick the layer that you want to be at within some amount of reason. If you wanted to, it would no longer be the internet, but if you wanted to, you can establish a line of sight peer-to-peer connection with someone across 100 miles using a directed antenna, right? So we could use quote unquote standard Wi-Fi hardware, put a special antenna on it, put it up as high as the legal limit allows for our jurisdictions of our homes, and point the antennas at each other, and we could have a true peer-to-peer, with no intermediary hops, and unless you want to start saying that there's a lot of atoms involved and a lot of light involved, and not all of the light. We didn't fashion the Wi-Fi router ourselves. You have to give some sort of trade-off as to where you draw the line in the sand. But the internet was designed to be peer-to-peer federated. It's designed to be an efficient way that is censorship resistant, to being able to communicate. Well, I don't know that it was so much censorship resistant as resilient, and resiliency implies censorship resistance. So if something is highly resilient, then if you take down one node, if you take down one switch, then there are many switches, and so traffic will simply divert to another switch. So we have lots of blips where a main internet switch dies that's up in the upper echelons of the chain, and another switch simply handles the traffic because the switches have, like I said before, these routing tables, and they just find an efficient route to get from point A to point B. And some packets may not go along that route, but as the route that's the most efficient is established, then packets will go across that route. And if there's a disruption, packets will start to pick different routes just heuristically from these connected routers. But yes, you have to have a subscriber that you connect to, such as Google Fiber or Comcast. And then that subscriber is going to connect to a backbone. And then that backbone is going to connect to another major metropolitan area where there's another backbone. So When you see that, you can probably imagine this in your mind, the nighttime view of the Earth, and you're seeing all these stars, and then you're seeing all these lines representing travel. Uh, I would imagine that the internet almost perfectly replicates the population density in terms of where the backbones are and where the lines are laid and how the travel occurs.
Got it. Okay, so I'm looking at the list of things that we said that we might be discussing. So just to rattle it off real quick: root nodes versus seed nodes, DNS versus hash table delegation, names versus hashes, TLS versus SECP 256K1, redundancy, failover, failure. Those are, I think we'll get into some of those at some point, but I, let's talk about DNS for a second and um, what this layer is of name, the naming system on top of the IP system, and how that all came about and why that came about and why we have that. So DNS, what is it and why do we have it? What are the pros and cons versus using just communicating between IP addresses?
So DNS is a layer that can go on top of IP. It could ostensibly go over top of other protocols, but none of them are that important. So DNS is not, it's not confined that it could only ever work with the IP system as we have it today. It is simply a name registry. So you can think of it as completely separate from anything to do with IP, both politically and systematically, but that works pretty well. So it is a it's a phone book. That's what it is. It's an IP phone book. And it started with originally when you wanted to connect to different computers, you would communicate with whoever owned it, find out what their IP address is, and then you would have a host file on your computer where different resources that you were interested in are being hosted. And you would name them. So you might name one email.example.com and another one www.example.com and another one, I mean, this is probably a little bit too far ahead in terms of where we're at historically at this point, but and Ryan.com and AJ.com, whatever. And so I would have a list of files. Well, it wouldn't even have the .coms or anything yet. It would just be a name, just an arbitrary name. Ryan, AJ, email, data, whatever. And so it's just a list of a simple pairing of here's a name, here's an IP address, here's a name, here's an IP address. And then when I wanted to access another computer, I could access it by the alias that I created. And that became known as Yellow Pages or YP, named after the phone book. And then as it evolved, it eventually became DNS, and there was a better standard for more types of information to put in there. So not only and we're there's it's such a great system, and we utilize so little of it. It's just sad.
Okay, so just wow, no, is this like trying to follow me? Anyway,
Yeah, I don't know.
I'm not
People
touching
online
it at
don't see it.
all.
Yeah, people online don't see it though, but I don't know what it's doing there.
Okay. Uh, so you're saying that on my computer, back in the old days, I would
And
have a,
today, it still
and
exists on the
today,
computer today.
I would have a file on my computer. You called it what? Host names?
Hosts.
Hosts. A file named hosts somewhere in my computer, and it would just literally have a name of some sort and then a space or something and then the IP address. So instead of me having to, as the operator of the computer, instead of me having to remember, 156.292 blah blah blah, I put a name to that, and then when I'm operating my computer, let's say we're really back in the old days, and maybe we're putting that name into a web browser. Well, I don't know. I guess that's how we still do it. We're putting that name into the web browser, and then my computer, some software on my computer, is then looking up in my local file that I made personally, hand typed out, whatever. It's just doing a mapping of that. Say I have a name called AJ and an IP address of blah blah blah, and so that when when that web browser tries to connect to AJ, I'm forgetting the dots on purpose right now because we haven't talked about that.
Right.
If I say AJ, that tells my browser knows to look up the hosts file and then get the IP address that corresponds to AJ. So now, is that basically how it used to work? Like
Yeah,
literally?
and it still works that way today. There's a little bit of layering to it, so there can be more than just the file. There can also be a software layer where there's a more than one file. But when you use an ad blocker, this is how ad blockers work: is they just replace uh, urchin.com, ads, googleads.com, so on and so forth. They just have a list of a few hundred domains where when the computer resolver goes to resolve the domains, it redirects them to a site that says 404 not found.
Hmm, gotcha. Okay. So now tell me how these naming conventions got made. And I'm always hung up on a little bit of this registration process because if I have, you know, in my local file a line item that says AJ is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, whatever that, if that worked out. Um, who's to say that somebody, uh, I guess, yeah, tell me how these numbers get registered so that there aren't collisions in the network.
Well, so back in the old days, things were done manually. Before the internet got to the point where you would have it in your home, uh, the numbers were manually assigned. They'd be on a sticky note next to a workstation with, and there might be more than one number because there wasn't just the IP system. There was also the Samba protocol for MAC addresses, and so you might have to manually configure these things. And eventually, we got DHCP, which is the dynamic host client protocol or domain. I don't know, but we got it so it's automatic, where you get an address based from the pool that's available. So, like I was saying before, an ISP is going to buy 1 million addresses. Well, back in the time of dial up, you'd cycle through those addresses pretty frequently because you'd have so many addresses, somebody would dial in, and you'd need to potentially pull an address out of the pool and assign it to them for their session while they're online. And then when they disconnect, it goes back into the pool, it's marked as free, and so on and so forth. So for computers, devices, your phone, some of the devices you have around your house on your local network, it's all in layers, but there's pools of addresses, and when a new device connects, it's dished out from the pool. And you have probably had the experience at some point in time where you couldn't get online in a crowded room, and the answer may not have been that there wasn't enough Wi-Fi. It may have been that the router was misconfigured so that it only allowed 200 devices, and the pool of IP addresses that it could distribute wasn't great enough. Also, back in the old days of dial-up, if everybody was getting online, just like you get the busy signal on your phone, if too many people are trying to use the phone at the same time, you could try to dial up and there might not be an IP address available for you from your ISP. And so you might not be able to get online. So nowadays it's all done automatically and hierarchically. You connect to a box that has some pool and it's connected to some other box. And at the highest levels, it's a lot of static routing, I believe, still. So when you get up to the level of the backbones have a lot of static routing because they don't want it to be dynamic. They don't want it to be attacked. They want it to be efficient, and they know how to tune it to be efficient. So they will manually edit in some routing information about how one address gets to another, for those backbone services. And again, I'm not an expert in this, but I think that that's basically how it works.
Okay, so if I could dumb it back down again, um, it makes sense to me how if I'm in control of that hosts file and I say that the word AJ maps to this number, that my computer would then follow that and do the right thing. But what doesn't make sense to me yet is how I can type in a word, the two letters AJ, and it maps to that. But in a browser setting, I guess what we can bring in the aj.com just
Yeah,
to
yeah, yeah.
make it
You
more
have
familiar.
to, yeah, because
Right.
if we're going with registered domains, then because at some point it went from okay, it's my computer to we have a name server, a YP server in our work organization, to then the ISP is handling part of that, and at that point you start to get into the .com where it's okay. We want a way to be able to register names across the globe
Yeah,
and
and
be
that's
able
what
to
I'm getting
figure out
at,
where things are.
because if I put aj.com and my host's file maps it to this address, maps it to this number, that's going to collide with somebody else that wants to put, he knows a different AJ,
Yeah,
and he maps his aj.com to some other number. And
right.
so how would the browser vendors know how to reconcile that? And so there's obviously some registration process involved with the .comness.
Yeah,
And
and
so
so this gives
explain
you
that.
a layer of abstraction over the IP system and a different layer of decentralization. And this one is a little bit more arbitrary, like the phone system. So there are root nodes, which is to say that there's a fairly well known static list of nodes that are in charge of the TLDs. And so when you register a TLD
What's a
such as
TLD?
.com, .google,
Top level
.tech,
domain, right?
yeah, top level domain, sorry. Top
That's
level
that,
domain.
and examples are .com, .org, blah blah blah.
Yeah. So when you register one of those, you have to guarantee to provide servers and that will be able to handle lookup tables for that TLD. So if I
So
have
when you say you,
aj.com,
you're talking about Google,
the service
or
provider.
the service provider has to provide that.
Yeah, so name.com, for example, or yeah. Well, sorry, actually, no, I said the wrong thing. That's the registrar. The TLD is the actual whoever owns it. So VeriSign, I believe, used to own .com, .net, .org because of antitrust monopoly stuff. There, I'm not really quite sure how it works now, but darn Obama actually gave up our right as the United States to .com, .org, .net, and he handed it over to an international organization. I may have gotten that wrong. I remember being in the news. Maybe it didn't actually pass and go through, but I believe that we as the United States no longer have a firm hold on the .com, .org, .net. Um, and so, but whatever organization, the ones that are privately owned, which are, for example, .tech, .google. .google is exclusively privately owned. There's no way to publicly register a .google. Only the company Google can register a .google. It is completely privately reserved for itself, but it has to guarantee the root level name servers anyway. Same thing with all of the other ones. The root level name servers have to be provided, and these root level name servers, and I might actually be one layer off, but let's not split hairs because there may be one layer up above, which I think is A through K or something like that, which is what all the TLDs are registered in. So I think there is one more. I think the root name servers have the TLDs registered. The TLDs have the SLDs registered, and then from there it's all anyone's game. There's not there from that point on. It's completely up to you how you want it to be organized, and you can split your subdomains onto different servers. You can you don't have to host your whatever.com on the .com servers. You can just have a pointer from the .com servers to your own servers that host whatever.com. So it's incredibly decentralized, federated, and not just from the technical level, but also from the political level. It's not as decentralized as I'd like it to be because there are just a handful of companies that own most of the top level domains, such as .tech, .biz, etc. But each country owns every TLD has its own charter. So every country is given a TLD. Some of the countries just sold off their TLDs because they didn't realize that they would be participating in the internet. So there's a lot of free hosting sites that'll have a .wc or something like that, that is just from companies that decided to sell off their right to their TLD, but they have a charter. So if you get, for example, a .io, which is really popular, that's not necessarily under U.S. jurisdiction. That's under the Indiana Ocean or India Ocean. I'm sorry, I don't know my geography that well. Oceania, India. I don't know what the name of the country is, but it's some sort of thing that .io belongs to. Same thing with all of the two-letter TLDs. They are explicitly reserved. And there's also reservation of three-letter TLDs, although this is an inactive reservation. They're not actually in use, but every country has a two-letter code and a three-letter code. All of those TLDs are reserved. So for example, .eth for Ethiopia is reserved. It could never be used by any other project unless they bought it from Ethiopia, and it'd have to actually go into registration. Right now, it's just reserved. So it's reserved for non-use right
Okay.
now. Anyway, but you've got all that, and they have different charters. So for example, ironically, one of the most liberal TLDs that you could possibly use is .gop, which is owned by the American Republican Party, but their charter states that you are free to use the domain for anything that you want. It explicitly states that we do not restrict how you use the domain. A lot of top level domains, for example, .gay, I am almost certain, I don't think I've read the charter, but I am almost certain that you would find in its charter that you are not allowed to have what could be considered anti-gay hate speech on a .gay TLD. That so you have rules like that, rules potentially about hate speech, or whatever that's defined as, with these different TLDs. So .republican is actually owned by the same organization that owns .democrat, as well as I think .red and .blue and .black and .white and a bunch of other just
Hmm.
random seeming TLDs. But they all have charters. And so you have to be somewhat careful when you pick a TLD to register to, that its charter aligns with the things that you believe in. .dev and .app are owned by Google. .dev and .app are kind of unique in that they require that you're only allowed to use encrypted connections for HTTP over them. You're not allowed to use unencrypted HTTP on port 80 with a .app or a .dev. That's technically enforced. It's not legally enforced. You can legally run an unencrypted connection, but no browser and increasingly client software refuses to make an unsecure connection to those types of TLDs. So lots of
Okay.
stuff there.
Okay. So to
And you can buy
me,
your own. You can buy your own TLD, as Google has done.
yeah, and that sounds a lot like a constitution, right? Like the United States has a constitution, which it's has a charter that's supposed to grant you certain rights and establish the relationship between the states and the federal government, those kinds of things. But obviously, that has, how's that working out, right? So I would assume that these charters could do the same thing, like GOP, like you said, it has one of the most liberal, in the classical sense, charters that just basically allow you to do whatever you want to do on your .gop domain. But who's to say that they don't change that?
Yeah, and so if you are interested in doing dangerous wrong thinker things, then I think that you would want to diversify. Probably the best one, because I said .gop, but probably the best one to use is .com and
Okay.
.org.net, the core ones that have always been available, because of the way that they've had to go through these antitrust, anti-monopoly deals, and because there's so much precedent that they have been used for anything, that unless you're trying to host the KKK, you're probably going to be able to host it on a .com.
Okay.
I mean, you'd have to be a real extremist, universally understood as um, trying to facilitate depriving people of life in a direct fashion to get banned from a dot com. Um, and then there's laws that, of course, you're not supposed to scam people, et cetera, et cetera. But the dot com is, because of its history, is also one of the most liberal of them all, because it was before it became cute to uh, put politics and TLDs.
Yeah. Okay. Um, so you mentioned, I think you mentioned uh, the term root nodes and seed. I'm not sure about seed nodes, but is root nodes anything that you're talking about, or is this specific to Dash and cryptocurrency, or
So
how does it?
root nodes is, there's the TLDs and then there's the SLDs. Well, there's the root nodes that host the TLDs. There's the TLDs that host the pointers for the SLDs, secondary level domains such as the whatever and the whatever.com. And then you're off to your own. You can choose to continue to host where you made the registration, or you can take your hosting somewhere else for your name service. But everybody has to connect to the root nodes, or there are what are called alternative roots, um, which is where you can basically modify the software on your computer to say, hey, rather than and there's a sliding scale to all of this as to what layer you want to connect at, but you could choose to reject the entire internet system as it exists and have an alternate set um, of root nodes. And this is precisely what has happened with .eth. So .eth, in violation of the international standards governing country codes and reserved names, the .eth people have decided that they want to have .eth for Ethereum related stuff. And so they said, the heck with all of the protocols, we'll just see if we can go around it. And if you get enough groundswell that you can get people to subscribe to your alternate route, then there are some advantages that you could potentially get out of that. Now it's really hard. So
An
they've
alternative route you're talking about, instead of your computer contacting
the
the
same nodes that
authority.
everybody else contacts
Okay.
in
To
following the chain to the TLDs that you're subscribing to. I can make my own .com server, and the
right.
D
Okay. And meaning that means that whenever your browser looks up a .com address, instead of contacting something that is it hard coded into the browser or something, instead of contacting that default, you're telling it to contact some other IP address to serve you the the routes to get to whatever um, x.com you're looking for. Is that what you're saying?
Yeah. And so this is a sliding scale. Typically, when you leave your computer unmodified, you're going to get the results from your ISP, because you can't download every node onto your computer. Well, maybe you could. You might have enough space on it, but you're not going to download all of the names across the entire name system onto your computer and keep them up to date and in sync with people publishing, because one, they're not publishing to you, they're publishing to the server that they've chosen to subscribe to. And so it's your responsibility to go fetch the information from the server that they have delegated that to. And so typically your ISP is going to handle that caching and whatnot. If you go to look up google.com, your ISP is going to, well, I mean, it's probably going to be cached locally on your computer once you visited it a couple times, but or your router. But your ISP at least is going to keep a cache of the most common domains that are being used by everybody, so that it reduces network traffic and it reduces latency. So the domain name system has a time to live on every record. So you can say, as Google, we do not expect to change our IP address for the next 6 months. So if you've gotten our IP address in the last 6 months, you can choose to not ever reach out to us again during those 6 months. And then sometimes during a failure, where there's connection failures, software may be smart enough to invalidate the cache and then go do a new lookup. But you've got lots of layers in this chain, and it's all to create efficiency. But you can always you can tell your computer, go directly to the root servers and crawl down. There's a tool that comes with just about every computer and device called dig. And if you do a dig plus trace, and give it google.com, you will see it scroll through all of the servers that it connects to from the top down, rather than what it would normally do, hitting the cache at your local ISP at Comcast or whatever, and then using that more efficient cache. So you can bust all the caches and do the most inefficient thing. So also you can have an alternate route, and you can get people to subscribe to that alternate route. The problem is that the encryption's not going to work because, well, you're going to have an alternate route. You're going to have to install alternate certificate authorities on your computer. No one's going to be able to visit any of the sites that are on that unless they configure their computer to do that as well. So you can get browser plugins that will do this for you. That's what I was going to say with .eth. They also have this thing with Cloudflare, where Cloudflare is kind of capitalizing on some of the hype. And so Cloudflare does, I think it's .eth.link, which will go to the alternate routes for ETH and look up things, and it just adds one more layer. .link is that they own ETH.link, and so they map ETH.link, which is registered, to .eth, which is not registered. But then you also have this other problem of you can't get any of the encryption to work because you can't buy an SSL certificate for .eth because none of the registered certificate authorities are registered for being able to issue certificates for .eth, which means that then you have to set up your own custom certificate authority. So now you need to you start to replicate a lot of the systems that, although they don't all work perfectly, they work fairly well, and over the decades have become more and more politically and technically decentralized for a system that is less secure, less efficient, etc.
Okay.
I'm going to catch up on some comments real quick. Audio is low. Maybe was that because I was leaning back here? Is that why the audio was low?
I bet it.
Or was it? Ryan sounds good to me. Ryan, just say something real quick.
Something real quick.
Okay, yeah, your audio is a little low. I'm going to boost you. So I'm going to, let's see where you are right here. So, yeah, .tk, that's one of those free domains. And then there was this question earlier. Are you thinking that the blockchain networks may be jeopardized in some way? Absolutely. I think that's totally possible.
We should probably get to that sooner than later after we get through these comments so that we can actually get cut to the chase.
Yeah. Well, I think there's just, that's pretty much it. There was a couple of other little bit of comments, jokes about free domains and stuff, but it's pretty much what we're at. So the system that we have, I believe, is really good. It's about as perfect as it can be. Well, that's kind of strong words, but
well, with the trade-offs, though, I think is what you're saying, because there seems to be this myth of perfect decentralization without any kind of negative repercussions. But as we've talked about, the internet is actually not decentralized. It's federated, which is good enough. And it
depends on your definition of decentralized, because federated is a form of decentralization.
Yes, I get that.
It is not decentralization maximist. That would be incredibly inefficient.
My definition of centralized is that fully centralized is every single person on a network contacts one person in order to contact another person. So it all goes through one hub, right? And then fully decentralized or distributed is that everybody has access to contact every other person. So there's literally a connection between me and every other single node on the network, so that no matter who I wanted to talk to, I could reach out to every single person. I have a connection with every single person. You have a connection with every single person, Oprah style. Everybody has a connection to every single person, right?
But that's my criticism there is that is purely theoretical. That has never existed in the natural world and never could exist in the natural world.
And so what happens naturally is that some people specialize in making these connections. And so like with the .com thing, or whoever some company owns the .com, and so if you're connecting to a .com, you're connecting through their registration. So that's what we would both call decentralized, because it's it's not centralized, even though it's not fully distributed. It's somewhere in the middle. So if you're moving from centralization to a direction where you don't have as much centralization, that's by definition decentralizing. Now, if you're moving from a fully distributed ideal, or maybe not even ideal, I won't use that word because I don't think it's ideal. If you're moving from a fully distributed, you have a connection from every single person to every single person, and then you move to a federated model, that would be a centralizing move, because you're becoming more centralized. It's
Well,
not necessarily a bad thing, because that you're gaining efficiencies that way, right?
it
But I just
actually
want to get the
still depends.
terminology down.
But I think that the terminology is flawed because you are considering it only along this particular axis of a physical medium. Whereas, so for example, the speaking of Bitcoin, the blockchain, there is nothing more centralized than the blockchain. If you look up the definition, if I go here and type define centralized, let me see if I can do this.
Come on.
No, I'm serious. I'm serious. It says, um, well, this time it's giving me different answers than it was before, but I have this on my the blockchain's not really decentralized video. A vast superstructure of control. So if you are participating in the hive mind, and every ant in the hive mind is operating autonomously, but it only does one thing, which is whatever the hive mind wants, then there is zero decentralization. So you can have every single node could be completely independent, but if they can only perform the function of the hive mind, you have no decentralization. So it's not just the axes of the physical medium, it's also the axes of the, I don't know what to call it, the political, the moral, the intent medium, because you have to have the possibility for variety in intent. If you have no variety in intent, you have no decentralization.
Okay. So can you clearly state a concern that you have with the architecture of blockchains? I don't like using the term blockchain because that's, to me, that's just the data structure that's
Well, but that's
connecting.
that's something physical or relative. It's the medium. It's the tangible medium, or I don't know what the right word to use is because of course it's digital, not physical. But that is the implementation. And so we have to talk about an implementation, because if we're only talking about ideas, then we end up in this place where anybody can put their stake in what their belief is. And then anytime you say, well, how are you going to implement that? They can just, oh, it's implementation details. It'll work great.
Okay. Well, what's your concern then? Can you state your concern? To me, like, this isn't a debate, because I'm not trying to say that you're wrong, and I don't think that you're trying to say that the blockchain is necessarily wrong. It's more that we can improve on it, and that's what I want to try to find out is how are things currently structured, and how could they be better?
Well, let me start with this. The natural way of things is to reach a balancing point of specialization and decentralization, right? So, what we want is to maximize efficiency and throughput, and maximize, I'm using that term loosely because we don't need the absolute maximum efficiency and throughput, because that would require dictatorship, which would then no longer have freedom of intent, but relative efficiency and throughput. So we want to be able to do more with less resources, or with fewer resources. We want to be able to accomplish more net good. We want synergy. We want the sum of the parts to exceed the sum of the whole to exceed the sum of the parts.
Yeah. Well, I'm making myself guilty of the thing that I tried to not do at the very first. I'm going to make another analogy to an economy.
Sure, I
Some
think that
people
works great.
some people insist on raising your own chickens and creating your own tables, and you're doing everything completely autonomously. You're raising your own cows and milking them for your milk, and that would be a system that's you're fully robust. Okay, you're independent, right? But what you're giving up is the efficiency gains that you have through a market, where instead of you raising your chickens and planting lettuce, you can just go to the grocery store and buy something from the farmer that raised the chickens, and the farmer that created that made the lettuce, and the, you know, uh, all the things that you can buy from a market that you didn't have to build. So that's, I think, that balance that you're talking about.
Yeah.
And in the digital realm, in this blockchain industry, what does that mean? And so what is this balance that you're trying to strike? Because I don't
Mhm.
think that most of us want that fully independent life where we're raising our own chickens. People
Well,
want to be
and
able
if
to go
you
to the store. They just don't want to have only one general store, that, the commissary kind of thing, where you have one choice, and if you don't like, the beef that they have, it's tough.
and this is my problem with Bitcoin in particular, because I know that there's other systems that have come out better, but you only have one choice. In order to get anything done, you have to go through everyone. So it's not that any node can speak to any other node. It's that any node has to speak to every node. And there is no specialization. Every node contains the same data. Every node has the same capability. So it's not decentralized at all. There is
So it's
no,
very inefficient.
yeah. I mean, it is, yeah.
Eh, Okay, but now to play devil's advocate there, I think what some people would say is, well, that's by design.
Well,
We are
I don't
trying to
really,
create a system that's fully decentralized,
but
so
it's
that,
not. It's not decentralized. It does not
or
fit the definition of decentralized.
we're
It
trying to create
literally,
a system that's fully, I don't know what the term would be. What term would you give it,
I
that,
don't
that
care.
people are trying to
I don't
achieve?
really want to go too much into that hole. I bring it up because it's the worst example, but because it's the worst example, I don't think that it's worth a whole lot of time talking about it, because I think that anybody who's intellectually honest and who understands the protocols to some degree has to arrive at that conclusion. I don't think that there's people who are actually educated on the subject advocating from the technical standpoint that this is technically desirable. I think there's a lot of other emotions and feelings and politics that get involved, but I don't I I because whenever these things are brought up, the people who are in the Web3 space that are real strong advocates will immediately deflect to, well, we don't have to do that anymore because now we have this technology that works differently. So I don't really want to go into that. If I can backtrack us a little bit,
Sure.
root nodes versus seed nodes. I wanted to talk about this misconception of decentralization and non-decentralization. The internet that we have is very decentralized. IP address system is fairly decentralized. It's not as decentralized as the domain name system. It's not as resilient as the domain name system. It's not as it's in no way, shape, or form is the IP system as perfect, where perfect is being used as a goal term, not a literal term. The IP the domain name the IP system is not as perfect as the domain name system,
Okay.
and I see a lot
DNS,
of
domain name system is better than pure IP system, is what you're saying.
yes when you
I
add
don't think
DNS
people
on
know
top
what
of
that
IP.
means.
So my example is that I just see a lot of people in the Web3 space. They think that somehow by using only the IP system, they're going to create a more decentralized or more censorship resistant system. And what they do is they recreate some of the same problems that we had in the 90s with dial-up, and their minds are just, they seem to be, the light bulb hasn't turned on as to how the internet works and how we can utilize the benefits of the internet to get greater when I say decentralization, moral freedom, intent freedom, political freedom,
Okay. Well, I think
economic
everybody would be
freedom.
on board with that. That's a goal that most people in this space share. So, how can the DNS using the DNS system improve on just using pure IP system? And maybe before we answer that, we need to answer the question about how it currently works. So, like if you have a dash uh, in Dash platform. I'm debating whether to keep this general or to try to just make it specific to Dash. And I
We
think
could
it's
talk
just
about Dash.
let's just yeah. So in Dash we have this thing called Dash platform that we're all waiting on. And one of the main products of Dash platform is this SDK, Software Developer Kit, which is basically just a library of software code. It's a collection of software code that you can import into the code that you're writing as an application developer. And then that SDK does a lot of the hard work for you in connecting with Dash platform. And what I think one of the things that a lot of people don't realize is how those connections are made. So when you're using the SDK in your application to connect with DAPI, with Dash platform, what's actually going on
So
under the hood?
there's a lot that I don't know about that, but this is where I wanted to talk about seed nodes. So people have this idea that, for some reason, they just fundamentally misunderstand, like I was saying, IP and DNS, that in a decentralized system, it's decentralized, so there's no authority that can be shut down, except that there is, because the seed nodes, sometimes listed by a domain name, which I think is better because that gives them the freedom to update that, although also potentially comes with some security downfalls if they don't sign their DNS records, or an IP address. There's a list. Every blockchain related project, what defines the network is essentially everybody connects to these central nodes, and then the central node directs them where to go from there. So
And
the
do they
seed
connect to
nodes.
those central nodes as IP addresses or as domains?
So you have to connect to them as IP addresses at the protocol layer, right? The domain name system is kind of like a piece of paper. You can write whatever you want in it. We just have a lot of standard conventions about how to write an IP address and how everybody understands that. But the two systems are not, they're not related very much technically, other than that the one system says, "Hey, I have a record for this type of system." So you never connect to something by a domain name. You always connect to it by the IP address. But yeah, you connect to it by domain name as in that you get the domain name, you get to look up the IP addresses that are associated with it, which automatically provides another layer of distribution and redundancy and resiliency, because you can have more than one address at a domain name record. And then the client will, when it gets that list, will maybe round robin or maybe pick at random which address it wants to try to connect to. So I'm not sure exactly how Dash's addresses work, but all of them are .io, which I find to be, now I could be wrong about this, but I find that to be politically precarious, because I don't know that .io unequivocally, that their charter serves the interest of Dash, or even that the legal structure is something that is tenable to Dash. I don't know if the Dash community is actually complying with the legal requirements for a .io. I don't know what those are, but typically speaking, any two-letter domain, you have a registered agent in that country that is actually the one that owns the domain. Typically with a two-letter domain, you don't own it. You are not actually registered to the domain. You are, one of the reasons the two-letter domains tend to be more expensive is because you're paying a registered agent fee
Yeah. And
for.
you're saying though that Dash platform does connect to these .io addresses.
If
That
I
those
if
are
I've
the
seen the
seed
code
nodes.
correctly, yes, there's a list of seed nodes that's distributed with the npm package, and in there are four, if I remember correctly, maybe it's three, maybe it's four domain names that all end in .io. And so it's red dot dash node.io, blue dot dash node.io, something like that. So there's not the political decentralization that I think that there ought to be in this type of a project, And then,
Okay, that can be easily solved, right? We
sure.
just have to register some different domain names. So that doesn't, I mean, that seems like a valid concern, but that doesn't seem like a big challenge. So are there any big challenges to how you understand that we've got this set up that we could improve upon, or did you want to take this in a different direction?
I want to answer that. I want to finish the current line of thought first, which is that you're connecting to 4 nodes. So if somebody wants to take down the network, all they have to do is target those 4 nodes and they can take down the network, right? Because as soon as the device is cycled and it's not connected to the network anymore and it wants to go get information about how to connect to the network, if it can't find those root nodes, if it can't get to them, the network is gone. So the entire network essentially hinges upon 4 nodes. Now,
Yeah,
that's a little bit
you can have
unfair.
a network of 4 or 5 thousand nodes, but it doesn't matter if there's a four node gateway that you have to get through, right?
Right. Now there's as long as the client applications are running, they are sharing hash tables back and forth with each other about where other nodes are located. So once you get connected, I mean, you'd basically, in order for the network to be totally stopped, you'd have to have all the devices power cycle and none of them would have an active cache of the devices they were recently connected to. So the scenario I'm
Very
talking
unlikely.
about is actually pretty unlikely, but the same thing is true of the domain system with DNS. Is it's highly unlikely that every political actor will agree entirely the same way. Not that that's never happened before in history and in other areas. The empires have risen and fallen over you know arbitrarily executing dictatorial power. But I think it's really, really unlikely that every single owner of a TLD will politically turn against a group of people, and unless that group of people is really an anti-human group of people in a very strong and literal way. For example, I don't believe that the KKK has a website, and I think that um, there's a reason for that because their values are so. Um, if I understand correctly, to this day they still believe in burnings of people who have done no harm and gone through no justice system, right? So that would be such a small sliver of you have an entire world organization turned on a small group of people, but the small group of people is exercising a belief that is perhaps demonic in nature, right? So now that you could say there's a slippery slope there because you could say, well, for the killing is bad, but what about just looking at someone wrong or saying something wrong and da 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 da? Maybe there could come a case where something that is not physically harmful to society, people could completely rally against a belief or an ideal or something like that. It's within the realm of possibility, but this happens on the block the not the blockchain, but this happens in the Web3 networks as well, such as what happened with I think it was called Gab. I think we mentioned this on one of the previous debates, but basically people just started requiring that you have a blacklist that you kept of nodes that would not be allowed to connect to your nodes, and then they propagated that blacklist, and then they ideologically shut down an entire network. So these types of things, it's a sliding scale, but the problems can exist in both types of platforms. So neither one is perfectly virtuous, but the one that we have with DNS is certainly more efficient and certainly more ideologically resistant as it's presently constituted. So I would prefer to rely on the domain name system that already works, that requires less software. So you've got this whole entire custom SDK for doing worse what, well, some aspects such as the initial network connectivity, you're doing worse what's already been a solved problem.
How could you improve that?
Just use the system that we already have, and if you have specific concerns
I'm
about.
just not clear what we already have and aren't using.
So use the domain name system in the way that it already works. Don't require people to have this separate system that isn't compatible, that they can't use in their browser. So if I want to connect to somebody's uh, Dash wallet or their Dash node. I should be able to just do that via a, a domain name that's going to give me greater security in terms of I'm going to be able to choose which certificate authorities are allowed to be used for that.
So you're
I'm going to be able to
saying,
have TLS just built in that's well-known security.
okay, so you're saying we've got 4,200 nodes, master nodes on our network.
Yeah.
Are you saying I want to be able to just connect to one of those directly without the seed nodes? Is that what you're saying?
Yeah, I would. Yeah, I mean, I think that there would be a lot of, yeah,
And
it
is there
certainly should be
anything
possible.
that
I
stops you
should
from
be able
doing
to,
that right now?
I mean, I guess I can get the master node list, and then once I've got that, I could, create my own seed node list. So yeah, I mean, I guess I can, but there's no specialization right now, and I hope that there will be because I think 4,000 nodes that's really powerful. That's a really promising potential if you use it efficiently. You could do a lot for people with 4,000 nodes. You could easily service millions of people with 4,000 nodes. You can serve millions of people with one node, right? So
Mhm.
with 4,000, the redundancy, the resiliency, all of what you could do with that if you followed kind of the tried and tested paradigms. I'm not saying that we shouldn't explore other ones, but we certainly shouldn't abandon what we know to works to chase after things that we know don't work well and that don't, you know.
Yeah, I mean, I don't want to put you on the spot here, and I don't expect you to have a solution. I just want to understand what the problem is and what direction we should start heading.
So I think what we should start heading towards is working on things that are more peer to peer. We're still stuck in this vast superstructure mentality of, okay, there's going to be these service nodes and they're going to be a hive mind and they're not going to specialize and they're all going to do the same thing. So we need them to specialize for a lot of reasons. One, to keep for the specific use case of Dash, if Dash is going to become popular, if transactions costs are going to be kept low, you have to shard the transactions at the very least. You have to shard them so that different nodes can be responsible for different portions, so that you don't have everyone carrying the same full burden of all transactions ever.
Mm.
If all of these 4,000 nodes could be responsible for a few hundred megabytes and maybe you're duplicating a few hundred megabytes 5 times, you get a lot more efficiency than if you're duplicating several gigabytes 4,000 times. And if Dash is going to grow in popularity, then that chain size is going to grow. And if it grows enough, then the block size is going to have to grow to accommodate transactions. So but I think that there's a lot more opportunity here than just monitoring transactions. Helping people be their own bank, I think, is really interesting. And the way that you do that is through domains. People can visit a domain in a web browser, right? So if a person has a desktop wallet and there's a service node that is facilitating their access to their wallet where the encryption keys are on their desktop, and the service node is just help bridging that gap of turbulent network problems to get them there. Having service nodes that help me as an individual to access the things that I care about, not just being part of the hive mind, but actually facilitating. I mean, that's something that could truly be revolutionary for the internet today. Imagine if we talked about this before, but I imagine me being able to use my Dash Direct card, swipe it, because of the limitations of the credit card system as it exists today. We couldn't have the perfect scenario that I want, but I could have it. So I swipe it, then a webhook goes off to my wallet, letting my wallet know that some money has been used on my Dash Direct card. And then I could get that notification and I could decide, okay, this is good. I like it or I don't like it. And I could immediately, have the same benefits of fraud prevention from my own hardware with just a little bit of help from some service nodes if my network conditions are poor. If my network conditions aren't poor, then I can just connect directly without any problem. But a lot of people, they're in a college dorm, they're in an HOA, they're in a country that's run out of IP addresses, etc. So just providing that bridge layer of facilitation for things that Dash people want to do in a way that already works. And I'm not against reinventing the wheel. I'm just against reinventing the wheel in lieu of, or not in lieu of, what's the word? Ignoring solutions that work to go on this long, years long journey of a solution that probably, statistically speaking, won't work with unvetted technologies as one big rush. I mean, if you took it in bite-sized chunks of saying, okay, let's explore the benefits and detriments of the technology that we have used to its full capacity, not used like dial-up. You know, if you say, oh, the internet's not decentralized because all of the cloud and everything's modeled after dial-up, well, yeah, I agree, but that's not the way the internet's designed. That's the way that people have restricted the use of it. And if you open that up to being that more peer-to-peer functional, things can connect to each other, they can have names, you can exchange services back and forth between devices that you own, have kind of store and forward devices out on the network that facilitate users that are purely paid by user payments that don't have any adverse political or monetary interests that are really meant for that purpose. I mean, I'm sorry that I'm just rambling and I can't say it. My head's so
Yeah.
full of
Well,
how, you know.
I want to get back to some of these ideas about what kinds of services you have in mind, but maybe we should take a little break and read some of the comments.
Okay, let me see what we got here. So somebody said, "What about the dark web?" That was the Neverworld. I don't know if that was an honest question or if that was a troll. Because to me, the dark web just means places on the internet where people do stuff that's untoward. I don't think that there actually is a dark web, although I think some people reference that as Tor, which Tor is kind of a weird thing. It's highly inefficient. Somebody did want us to continue talking more directly about Dash. Decentralization doesn't exist because IANA exists. I strongly disagree with that because yes, there is a political body, IANA, but the same thing is true of Dash or of Bitcoin or whatever else, right? There is a political body that governs who the seed nodes are, and it's not you. So IANA exists and they govern things, but so does every other organization that is part of the definition of an organization. There has to be some sort of governance that takes place. It is not possible for everything to connect to everything else in the real natural world. Michael Jordan fans, blah, 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 not reading that one. For me, it's not the connecting to the SDK or masternodes that worries me, but what about that we want DashPay to connect to people's phones, and what if Google and Apple just took them off app stores? And then, yeah, you've got some, but again, if we're going back to this idea of you can just host it out of your house, not every ISP is going to block this stuff. Plus, everything's encrypted these days, so ISPs can't see, they can see some stuff about your traffic, but in a fashion where lots of people are running lots of similar software that handles similar purposes, such as transacting, it's difficult for the ISPs to know that the packet that you sent was a transaction that's encrypted was a transaction packet. So I think that the web is going to be more resilient than app stores are, and you can run web apps on your phone and they can have essentially the exact same capacity for something like what we're talking about with Dash, because all of the Dash stuff can be written in JavaScript just as well as it can be written in anything else. And the benefit is that it already is written in JavaScript. And I would imagine, I don't know this, maybe you can tell me, Ryan, I would imagine a lot of the Dash apps are actually using the JavaScript library under the hood in some sort of web view or some such.
I think that that was one of the main motivations for the design is to enable JavaScript applications to connect with the network. That's one of the main parts of the design, so that you don't need an app necessarily. You just use a standard web browser, and you can connect directly to the network. All right. So how are we looking on time? What have we gone through? We went through seed nodes, root nodes, DNS, DHT delegation. Do you want to talk about that a little bit? How it
Yeah,
relates to what we've been talking about?
just a touch. So when you connect to the seed nodes, they seed the DHT, the distributed hash table. Now, the DHT
So
is
what is that?
specific to the network. It's like the DNS system, except that it's hash based. It's not arbitrary names. It's hashes and prefixes that help you connect to other nodes. So if somebody gives you a hash that represents a computer, part of the idea with the DHT, because that was developed specifically for BitTorrent, if I recall correctly. But
Is
again,
this
this is
something in the Dash network or not? The
yes,
DHT. Do we
yes. So
use DHT?
DHT is how things like Dash and Bitcoin and BitTorrent work. It's how the seed nodes help other nodes contact other nodes. So the DHT is the living cache of connected nodes on the network.
Hmm. Okay.
So imagine instead of being able to choose aj.com, ryan.com, you're just assigned a hash. And so your computer, when it communicates with other computers, is going to use that hash as an identifier. All hashes of all um, users are registered in the DHT, and the DHT is similar to the blockchain in that it's a hive mind. Well, actually, I think the DHT was not the same because there is specialization in the DHT because it is the distributed hash table. So it is sharded out so that not every node has to know about every other node, but your seed nodes help you get connected to all of the other computers. That's why you connect to the seed nodes first.
Okay.
And so it's really it's the same as the DNS system from a functional perspective. Other than that, you just don't get to choose the names. But it's got the idea of you want some efficiencies. Um, and you want to be able to keep track of nodes as they enter and exit the network. And you want to be able to keep track of a node despite the possibility of its IP address changing. I think that's one of the benefits of it too.
Okay. Do you want to say anything about TLS versus the SECP?
SecP 256K1. That is what the elliptic curve that most of the Web3 stuff relies on, which is a little bit weird. I think they chose it because it was rejected by the NIST. I'm not sure on that, but I think that was part of the reason is that they believe that the CIA or the NSA or the DSA or the DHA or what, all the the MKB, KJB, whatever, all the three-letter organizations are potentially conspiring over the elliptic curve algorithms that we have. And so I think they wanted to choose one that wasn't chosen by the three-letter organizations. And I don't know. It could be that there's a backdoor in some of our cryptography. I think that if there were, I think we would have found out about it. I could be totally wrong, but I think it's one of those things where you're not going to be able to keep a secret like that for too long. It's too interesting. It's too powerful.
Okay, so but this is the curve that we use in constructing our public keys from private keys, right?
Yes.
So you've put this versus TLS versus so
So
define TLS and why are you comparing these two?
transport layer security. So basically, one, you're getting just you're only getting part of the mechanism. The other one, you're getting the full mechanism. And that's kind of what I was going to compare there is that with Web 2, TLS works pretty darn well, especially with the introduction of CAA records. One of the main criticisms of TLS was extremely valid was that the root authorities can and have been abused or abused their users. But with the addition of CAA records, which is Certificate Authority Authorization or something like that, basically you can issue with your domain name the certificate authorities that you trust. So you can choose, rather than saying that any certificate authority can issue for my domain name, you as the user get to choose which certificate authorities that you personally trust, which again just balloons the decentralized nature It fixes a major flaw in the protocol that was a centralized problem that now has been decentralized. So they're not necessarily equivalent. It's just that one is standards based. Every programming library on the planet can handle TLS. There are still programming libraries that have issues handling Sec P 256K1. For example, I was having trouble finding something that was written native Go that could do that. And that means that it requires a C compiler, which means that now the program's more complex. So it's just an example of something where, I don't know, maybe they made the right choice. But I wish that they had chosen something that was standard, because it would be easier to adopt. And I don't know that there's any, certainly there's no at this current time, there's no provable issues with the TLS system that are worse than the Sec P 256K1 system. You could say there are things in the TLS system that you don't like that could be better. But if you compare that to, and again, it includes elliptic curves. It does not include that particular elliptic curve. But, so this stack, there could be things in the stack that are imperfect, but your alternative is something that doesn't even include the imperfect things. You could choose not to use the imperfect things, right? You could say, I don't like this piece of the stack. I can choose not to use that piece of the stack. But to disregard the stack entirely, create something different, then it just puts extra burden on everybody. And unless, I don't know, there's a burden of proof problem here. Was it worth it to choose a weird algorithm that everybody has to implement by hand in every language?
Yeah. Okay. So just the high level on that was there's this transport layer security system that uses algorithms, cryptographic algorithms that are standardized, that we have great tooling for. And then on the other side, we have SECP 256K1, which is a relatively less standard cryptographic algorithm. And you're saying that, maybe it would have been better if we had stuck to traditional standards so that we could have better tooling and create better tooling. But either way, we have what we have, and I don't know if there's a suggestion here. You have any suggestions on this, or if it's just something that you're pointing out?
It's just something that I'm pointing out. There's no known flaw, as far as I'm aware, with the Sec P 256K1, other than that you'll see CVEs, that's vulnerability exploit reports. I don't remember what the C stands for, or the V or the E, but basically you'll see things that, for example, if you just do an npm install on Dash right now, there is a vulnerability that is labeled as a critical vulnerability in the elliptic curve library. And that may not actually be critical. A lot of times these critical vulnerability flags are a little disingenuous, and that they're critical, but only under such niche conditions that it truly doesn't matter. So I don't know what type of critical vulnerability it is, but you are lagging behind the industry standard securities, because most of the Web3 space is marketing. Very little of the Web3 space is tech, and relative to the marketing. And so you're seeing these technological things are falling behind and not keeping up on par with their standard counterparts. But again, I think that the algorithm is probably fine. It's just there's a lot of disadvantages to using something custom in a space like this.
Yeah,
That
makes
is
it
just
harder
more
for
costly.
developers.
Yeah.
Okay, should we read some comments and see if there's anything to riff off there?
All right, let's see. Dash is amazing and fast and cheap. And it is. And it can only stay that way if either it never fulfills its goals, or if it abandons Bitcoin maximalism in favor of really focusing on that digital cash aspect. Now, right now, I don't think there's any problem. It's not popular enough for there to be a problem. But if it, blazingly fast, as the JS frameworks like to say. 2008, man, I have to think about how standard those standards were back in those days. TLS, for example. Yeah, it's been standard for, well, it was called it was called SSL before, and the elliptic curves were chosen previously. The 2008 was not that long ago. It might feel like a long time, but 2000, not a lot has changed between 2008 and now. Um, when you Apple came out with Apple Silicon, that's probably the biggest thing that's happened in all of that time, technologically speaking. And there were some major advancements in ASICs and GPUs. How can we get Dash payments into Home Assistant so anyone can easily build a vending machine? Yeah, this is what I want to know. Honestly, that's the kind of level that I'm thinking about.
What? How can we get Dash payments into Home Assistant? I don't know what Home Assistant is. Why don't you tell us that?
I think that that's the Apple branded version. I'm not sure if that's the Google or the Apple branded, but essentially, how do you get it so it works on apps and devices in your home?
Hmm. I'm guessing this is some kind of voice activated command based thing. Is that what this is? Like some kind of Alexa
So
equivalent?
I think that it's the system of which that is a part. So it's not that the Alexa is the system, it's that the system has Alexa, and Alexa is one of the ways of interacting with the system. I could be wrong about that. Uh, 2008, I was hacking Facebook because they had no TLS. That's right. I remember where I was when I first realized I could watch other people's Facebook messages. I remember the chair I was sitting in when I opened it up to do that. Oh, it's an open source automation OS. Okay, so I thought I was totally off base there. So Home Assistant is not a reference to the Google or Apple uh, products of similar names. It is a reference to an open source automation OS. But yeah, I'm there with you. How do we get it so that we can get vending machines to be able to do that? And that's
Okay. Well, what else? I'm not sure. Yeah, I fear that some of the early parts of the conversation were probably too basic for the uh, initiated among us, and the latter parts of the conversation and other parts were probably too technical for beginners to deal with. So I'm not sure if anybody got much out of this. But what do you think? Did we accomplish anything here?
I guess we just have to share and find out. I'd be interested. We've got at least 11 people watching right now, so some people are interested, trying to learn.
Yeah.
If y'all have any specific questions or in specific questions, go ahead and drop them now. But yeah, I think the main thing that
What's your takeaway? Yeah.
well, it's not my takeaway. The main thing that I am hoping to get across is I don't think that I did this particularly well because my head gets so full of things when I start thinking about possibilities that it's hard for me to generate a linear sequence that's clear and understandable. But we have an opportunity because the purpose of Dash is not to be Web3. The purpose of Dash is not to be better Bitcoin. The purpose of Dash is to be digital cash that you can use to make everyday purchases, that you can
Fully
take
agree.
your financing into your own hands. And that does not have any tethering to any of these, what I would consider quite antiquated technologies. Um, there is no moral rule that says because Bitcoin chose to use an incredibly antiquated model that it is decades behind the Web 2 model, that we'd have to stick to those types of models to build these things. And a lot of the myths about how somehow using IPs on a DHT is more decentralized than using the domain name system. I want to dispel that so that people don't put themselves into this box of we either have the dial-up age or we have the stone chain age that comes after it, but in all ways of innovation seems to much precede it. Well, not always, but there's some things there that the consensus algorithm I think is really that's the you know, we don't need forever storage. We don't need a hive mind. There, to some degree, you need a hive mind for the consensus algorithm to work, but you only need that. You can specialize that one aspect and say the hive mind around the consensus algorithm is what the hive mind is useful for, but every worker in the hive mind can still specialize for other tasks, and concerns of storage and networking, and I just think there's so much that can be done if we take a look at the design of the internet, the way that it was intended to be used, and we say, how can we help people achieve that level of peer-to-peer? And how, and instead of saying, oh, it's useless, people will never be able to use their own computers and devices to own their finances, we have to shift from the banks to the service nodes. How can we get the mindset of how do we shift from the banks to people's devices and help this, let the service nodes be a bridge, let them fill in the gaps, let them do the store and forward, let them do the proxying, let them do the facilitation, for the bits that are lacking, and let us develop those apps that will run vending machines, and whatnot, with the service nodes as a node in the network, not the network.
Hmm. Yeah, I would love to see. I think we need to explore this a little bit more because it's still a little foggy what the differences are to me between, interacting with a service node. By the way, we call them service nodes, AJ and I, because we don't like the term master node, but that's
And
just
only for the reason that it sounds too technical. It sounds stupid. Service node sounds more friendly and welcoming.
well on service node. I
Well,
mean,
me.
yeah, me too. It's also more accurate because it's describing what they do. They
They
serve the
don't
network.
control the
They
network, they
don't
service
master
the
the
network.
network.
Right.
But anyway, so in terms of like the distinction between interacting with a service node for a service versus interacting with the whole network as a hive mind, as you say, I think that we need to flesh that out a little bit more. Personally, as an amateur developer myself, I I would love to see some kind of just a JavaScript runtime on a handful of these service nodes so that I don't have to contract with AWS or any of these cloud hosting services. And I don't need 4,000 of them. I just need one. And so
Well,
I
for
think that might
redundancy, you
be
need maybe five.
right. As a network, we might need, you
Oh,
know,
and we do
uh,
have some good comments up here just to make a note. Keep going.
sure.
Say what you're saying.
So that's kind of what I would like to see. And this whole smart contracting thing, I'm not sold on it. I'm sold on it from the perspective
Is Dash
of
even doing that?
no, Dash hasn't done that
Okay.
yet, but there are many people who are pushing for that because pretty much every other blockchain does it. Like Ethereum is the one that made it popular, and then every other blockchain that comes out these days is a so-called smart contract blockchain, which basically means that the network runs instances of the EVM, the Ethereum virtual machine. And that's great for smart contract developers, but what about all the blockchain develop, or what about all the normal JavaScript developers that just want to run some standard JavaScript code, backend server side JavaScript code, or some Node code, or some Go code? I said Node, I meant Go code, or some Rust code that serve these traditional languages that you wouldn't have to compile it. So I understand that there's pros and cons of either approach, but that's just the kind of conversation that I want to start having. Is let's 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 look at the way that the internet works right now and try to serve uh, the immense user base of traditional developers and not get so pigeonholed into this
Yes.
newfangled blockchain Web3 world of Solidity contracts, and just try to see if there's a more traditional way to get things done that we want to get done, and then use Dash as payments for those.
Yeah. Yeah. I think developing the ecosystem around things that people, well, that realistically solve problems that and efficiently. We don't want inefficient solutions. We want efficient solutions. We want to maximize our potential, not minimize it. Going to read off some
Yeah.
comments. Seems like a good pause point. So videos are amazing, guys. Congrats on the great work. Thank you, Studio Z. Appreciate the kind words. Thanks for the conversation. Really liked it. Thank you, Josue. Fully agree with AJ. I think that was in regards to what we were talking about with back in the service node portion. Regarding DNS discussion on how the namespace is carved up between identities that own it, how does this tie in with what Dash platform is doing with usernames? And that is a question I do want to take a second to talk about, because this is one of the things where I feel like I don't understand what the implementation is. I'd like to hear what you think, Ryan, or what your understanding is, but I just intuitively, I just don't have a good feeling about it.
Can you reread that one? I can't see it right now.
Yeah. Okay. Let me get this back up here. So regarding DNS discussion on how the namespace is carved up between identities that own it, how does it tie in with what Dash platform is doing with usernames? So I think he's asking to. This is Great Wolf, by the way, asking how do we compare and contrast that with the Dash platform?
Hmm. I don't know. I'd have to think about that. I'm not sure if I understand the question.
Well, I'm going to take
You?
a shot at it. My frustration is that it's creating a new name network that's not going to work with anything that exists today, right? I want to be able to go to wallet.ryan.com and be able to sign in in some way, shape, or form. You approve me, and then me be able to get the XPub key that you dole out to me, that your wallet software doles out to me, and us to be able to have a pretty peer-to-peer relationship that way. That's what I would like, is that if we just had domain names as the usernames, we're good to go, and that can be functional. It's not tied into a specific app. We don't have to upgrade the entire ecosystem for anything to do anything, because that's another one of my concerns, is that the ecosystem is already so terribly fragmented. There's this religious, what feels like religious need to hold on to the fork of the Bitcoin software, rather than just calling it a hard fork. Say, you know what? Let the Bitcoin people do what they may. Let's focus on what we need, rather than expending all this energy and trying to keep up with and keep on top of and merge all the changes through with whatever Bitcoin's doing, right? It's just, we already have so much fragmentation. How in the world are we going to introduce yet another new technology that needs to be adopted on Dash Core and Electrum and iOS and Android? And then there needs to be tooling so that people actually integrate with it and make their vending machines and whatnot. So that's kind of my concern. Great. Well, if you can say, did I get that right or wrong or whatever? Datman Dark asks thoughts on these networks having custom VMs packaged with DSLs and what that means for dev adoption. I think that's kind of what you were speaking to, Ryan. That, yeah, let's have VMs on the networks that run maybe not custom DSLs. That's domain specific language. That's when you make up a new language. But let people run essentially functions.
Yeah. I mean, that's where as I dig into what's going on in the JavaScript ecosystem, what the craze that's right around the corner. I don't think it's here yet, but the craze that's right around the corner is this edge hosting,
Yeah.
and where you just host a function, a normal function, whether it's, I look mostly into the JavaScript ecosystem, so that's what I see. And people are, there's a push to have interoperability standards for JavaScript engines, and so that these different hosting providers such as Cloudflare and Dino and AWS Lambda, that they all can kind of come together on what does it mean to be a JavaScript engine,
I
and what's the standard libraries. And so, yeah, go
there
ahead.
there could be some good there, but it's telling such a small sliver of the story. It's kind of ignoring the fact that you need users, you need transactions, you need storage. Functions are lambdas. The
No, I know that
definition of it
that's what
is
I'm saying
that it's
though.
just data that comes in and comes out, and it's stateless, and there's no transaction. Well, not that's maybe not the right word, but a function is just I want this JPEG to be resized. That's a
It's
useful
ephemeral.
service.
Yeah, it's an ephemeral service. But that's kind of the point that I'm making, is that that is becoming very popular to have these edge hosted. They call it edge hosted because there's these networks of nodes that service these requests that are at quote unquote at the edge of the network, so that they have very very little latency between your computer and whatever node is servicing your request. Um, well, Dash has 4,200 nodes that could do that really well, and they could also do it way better, because not only could we host edge functions, we could also host edge storage. We could also have the authentication built in with Dash usernames or whatever username scheme we decide on. We could play around with what you're talking about, AJ, with your username is just a
But I think
traditional domain.
at the base level, you got to let people sign in with Facebook. That's not the ideal way that we want them to be self-sovereign, et cetera, et cetera. But they've got to have that option.
Well, yeah, sure, give them the option, but give other people the option that don't want to sign in with
Yes,
Facebook, an
100%.
option to sign in with your XPub key, or one branch of it or something like that. So that's kind of what I'm saying. So you've got payments, you've got authentication, you've got storage, you've got execution, that you could offer all of those things on the Dash network. That would be a very compelling service, I think, in today's climate, in today's developer ecosystem.
I think that it could be, but I'm
It,
not. I have some concerns because the model that created that was not a model that wanted to service people as much as it wanted to capture their data. You want to centralize certain aspects of the development pipeline so that it's more difficult to reproduce in other areas, and that it has less value when it's not connected on that system. But it certainly, for example, if you want to batch resized JPEGs, functions are a perfect use case for that. You want to do an unlimited number of things very quickly, as fast as you possibly can, and you're only bound by CPU. You're not bound by the transactional nature, stateful nature the of somebody going through a flow, such as a payment checkout, where every part of the payment checkout, you're actually changing the state both on the client and the server of what their interactions are. And then at the end, when they actually check out, you're doing the commit. But all the steps in between are all stateful. So I don't think it's good for the general business logic. I think it's good for the discrete business logic, like
yeah, yeah. I
resizing
don't know the
something.
details, but those are just kind of some of the things that I'm thinking about. And also, just one last thing to say about that is that I recognize that the Dash network is primarily there to service payments and not necessarily being a cloud.
Yeah, but
The cloud nature of it would just be a form of bootstrapping a user base.
yeah, it needs to bootstrap the economy. There
Yeah,
needs to be a Dash economy. So I want to get into this comment here. We need users and wallets that connect and are as easy to sending as sending a text message. I think crypto will figure out the best use case for crypto is money, and this I'm on board with. I, as part of the incubator, well, I haven't proposed this to Ryan directly yet, but I talked about it. I want us to have a wallet thing where you can send money, just you can send it in a text message. And when somebody, I think I did talk about this because this was another reason for domains, is that if you send the money in a text message and when they click the link to open it, that they can go to a domain that is a domain that you trust, such as your own domain, your own wallet, your own hosted wallet, hot wallet, whatever you want to call it, then they could get redirected to get the app on their phone when they don't have it, and then immediately be able to take the money without any back and forth interaction. You can send the WIF, the wallet import format private key with the money on it, via URL in a text message. They click it, they get the app, they get the money. Or even they could use your wallet. I mean, if they click the link and it's your wallet is the link that it comes from, then they could just be storing their money in your wallet until they decide otherwise. Where
Yeah,
wallet is a very loose term.
it's a bit
Not
of a barrier to entry when you have to ask somebody first download the wallet. Then it's going to ask you a bunch of security questions. Then I can send you money. So what you're saying is, let's have a way to send somebody money that they can claim, and they, in the claims process, it's taking them, it's walking them step by step down through the process of downloading it's taking
it.
them through that process, in the process of accepting the payment, rather than having the prerequisites of having the wallet before they can accept the payment.
One of the things that made Venmo very popular in the early days is that Venmo just sent the money. Venmo said, "Here's the money. How to get it into your bank account is now your problem." So it totally flipped the model on its head of, well, let me convince you to get this app and then I'll send you money. It was, I'm going to send you money. Now, if you don't get the app, you're wasting money.
We definitely need that. We definitely need that.
Yeah. The concept of a smart contract will be void if there are no service nodes. Yes, that's correct. Is it possible to own a TLD where it's legally owned by Dash masternodes and then use that as a root for Dash usernames? Yes, we've talked about this. Yes, it is. The starting price is about $250,000 to begin that process, but you can do exactly what Google and Apple and TJ Maxx and TK Maxx and dozens of other businesses have done. Legally, yes, because of the trust system, the Dash New Zealand Trust can own other entities. Those other entities can own a TLD. Yes, this is perfectly politically possible.
Just need to do it.
Well,
it's expensive and it takes time, right?
And great. Well, this is something that Ryan and I have been talking about. I've been stressing this for months, and I'm hoping that I'll be able to start building it, maybe I don't know, within a month or so. But so the process for this, it's not just you go throw out $1 million and say, okay, I want to have a TLD. There's a lot of process that you have to step stool, or not step stool, but you have to step through, to ladder through. So first, you need to be a reseller of domains. Once you're a reseller of domains, then you need to become a registrar for domains. So a registrar, so GoDaddy is both a reseller and a registrar, but you can think of it, the interface that you have with GoDaddy is as a reseller. When you go
give
buy
us
a
an
domain from
example
GoDaddy.
of two companies where one's a reseller and one's a registrar.
Name.com is a reseller, Enom is a registrar. So the registrars, typically you don't hear of them unless they are so big that they are the reseller as well. But typically, if they are the reseller as well, they open up their API to other resellers. So many domain resellers use the GoDaddy registrar because GoDaddy has some of the best pricing and their API is actually pretty good for all of their questionable business tactics and yada yada. But and then registry, then you can become a registry. I guess you could technically skip those steps, but I don't know of any company that has other than TJ Maxx.
TJ Maxx, like the TJ Maxx that my wife shops at, TJ Maxx.
.TJ Maxx.
They own, okay, they are
They own,
top
I think,
level.
4 of them. They have TJ Maxx, TK Maxx, and then TJax, TCAX something. They have, yeah, they have a bunch of them. I think they have 4. And that's the only company I know of that, as far as I know, they've never had a reseller or a registrar or any of that. They just they just went straight to it. But there's you have to show that you have the ability to pay there's quarterly fees. You have to pay at there's a bare minimum that you have to pay per quarter to be a registrar, or I mean a registry. Well, in each of the levels, there's different payments that you basically have to, sign up for, and so if you don't have the cash on hand, then the best way to do it is by establishing your domain business. If you actually have all the credit necessary in order to go through the processes, you could just skip the line and go straight to buying the registry, but you have to basically prove that you can sustain it. And the idea is that at some point you get so many users that your cost per user becomes as little, I think, as 10 cents, because I think it's so many tens of thousands or hundreds of thousands of dollars per quarter, uh, until the cost of your users at 10 cent per user per year is um, greater than that, at which point you're now only paying 10 cents per user per year.
Any other comments? Or should we close it out?
Yeah, I think we should close it out. We kind of went on various tangents there, which I think is fine. But I hope, I don't know. I get I I hope that this reaches some ears and opens some minds, and that my own way of being me doesn't get in the way of that, as it often does, because I'm very combative, and this is this and this and that, and somebody could just get stuck on one wrong thing that I said, and then just pound home that point and not get the big picture. The big picture is we have an opportunity. We're not confined to anything that existed before, and we're certainly not confined to not use things that work well and that could help grow the user base and service people.
Well said. All right, well, let's end it on that note.
All right, thanks for joining me and on this. I'm glad we did this. Thanks everybody for watching in. Glad to hear that you appreciate the tangents. And with that all said, I will close this out. Like, sub, follow if you want to. Check out the link to the Discord. Let me go ahead and drop that again one more time. I forget what there it is. There you go. So there's the link to the Discord if you want to do that. And with AJ is like the senior mentor that everyone could learn from. You feel that way for the first couple days, and then you think AJ is the senior mentor that people need to get away from. But yeah, thanks everybody. Catch you later. Adios.
All right, that's a wrap.